Here are a couple of problems for you to try. So pause the video, take a few minutes to work these out. If you need to rewind the video to look at a few examples, by all means do that. After you've spent some time on these, come back to this screen and we will look at the answers. Okay, from this first problem, we're thinking about what's the pair of numbers that multiplied together will equal -6. And without that coefficient there, thinking about the pair of numbers added together should equal what, here's where it comes into play, that without a coefficient, it's really a 1. So the pair of numbers we're looking for multiplied together are going to equal -6, but added together they're going to equal -1. And be cautious as you're doing this, because there's really one pair of numbers, only one pair of numbers out there that's going to work correctly. And for this one, it's -3 and +2. This bottom example, same approach. I decided to go for pairs this time. I wasn't seeing the pair of numbers right away, so I knew multiplied together they need to equal -60. And since added together it's a +7, I knew that the larger number was going to be the positive number. So I just went down the list. Here are all my pairs of factors of 60. And out of these pairs, the one pair that added together will equal +7 is this -5 with a +12. It's those numbers that show up in the parentheses, and there's our answer in factored form. Okay, another example for us to talk through. It's different because we see two kinds of variables. We see x's and y's both in this trinomial. It definitely looks different, but it's not totally unfamiliar. It's a little bit similar to these trinomials we've been working with so far. If you can block out the y there and the y squared there, it's pretty much of that form, x squared plus bx plus c. We just have a couple of y's plugged into some of these terms. There is a way that we can factor these types of problems without too much of a problem. And what I say is, go ahead and actually block those y's out. Take them right out of the picture. Lose that y from the middle term. Lose the y squared from the last term. So we're looking at a very familiar trinomial, x squared plus 6x plus 9. Our old trick still works, so we're looking for a pair of numbers that multiplied together are going to equal the third term. Added together will equal that middle term, +6. And it's going to be twins this time, both +3. So we have x plus 3 times x plus 3. So this is a fine answer for this trinomial right here, but remember, that's not what we started with. We have to think about, so how does this tell us what this trinomial would look like when it's factored? And there are some assumptions we can make. It's pretty straightforward. Just how we said, drop those y's at the beginning, we're going to just throw the y's back in at the end. And just how our x here and here, the ones that multiply together will give us the x squared. To give us a y squared at the end, we're going to put in a y here and a y here. So our final answer is going to be x plus 3y times x plus 3y. So we're not thrown off by an extra variable that you see in there. You're going to just lose that extra variable. So you're looking at a more familiar looking trinomial. Factor that, and once it's factored, you just drop the y's back in. Just how the x's are first and first, the y's are last and last. Comes to you up there last, goes back inside last and last. Here are three more that I'll give you a few minutes for you to work out. So pause the video. A few quick ones, two that are pretty standard and straightforward, and this third one deals with the idea that we just looked at. So remember that we're just going to drop those y's and put them back in at the right place once we have the expression factored. So take a few, put the video on pause, and come back to this screen and we'll look at the answers. Okay, from the first trinomial, multiplied to equal a +4 and added together equal a +4, twins, x plus 2 and x plus 2 was both +2's. this middle trinomial, it was a -5 and another -5 that multiplied together will give us a +25, but added together is giving the -10. And the last one, it's x minus 6 and x minus 6, and we had to throw those y's back in. So it's this x minus 6y times x minus 6y. The 6's two negatives multiplied together will give us that +36, and -6 plus -6 is going to give us the -12. What I want to show you here with answers when it's factored, when we have these twins, there's another way that these can be written, and it's important for you to know that it can be written in two different ways, and for you to understand that when we see something in parentheses and inside the parentheses there are a few terms, 2 terms or more, that it's really saying it's this x plus 2 written out twice. Both ways are acceptable, but as you go further in math, there are some times when you will factor something and it will be important for you to not leave it like this, but to take it one step further and write it this way, because that leads you to more steps to complete a larger problem. So I want to just make it clear to you right now that when we have these two binomials that are the same, that are being multiplied together, it's common to see it written as x plus 2 squared. I personally don't require one way or the other, but definitely you may encounter a problem where it's important for you to write it with an exponent. So x minus 5 times x minus 5 can be x minus 5 squared, and same with the last, it can be x minus 6y squared. And we're close to wrapping it up with factoring trinomials of this form, x squared plus bx plus c. Let's talk about what's going on with this trinomial, x squared plus 8x plus 2. So when we see a trinomial that we have to factor that has 3 terms, and the first term is x squared, those are the clues that we need to figure out the pair of numbers that multiplied together will equal the third term and added together equal the middle term. Okay? You see 3 terms and the first term is x squared. Your mind should begin to think, okay, I'm looking for a pair of numbers. So for this problem, a pair of numbers that multiplied together will equal a +2, but added together will equal a +8. So they're not out there. We don't have a lot of choices in terms of this multiply to equal a +2. Is it going to be 1 and 2, or is it going to be -1 and -2? And either way, we don't get a pair that adds up to equal a +8. So this is a trinomial that is not factorable, or you could call it prime, as in an expression that we cannot break down into 2 factors. And the way that you decide that a trinomial is prime is basically by running through your usual steps and concluding that that pair of numbers that you need, it's not out there to be found. And that's how we can say that it's prime. So this is our strategy for factoring so far. Each problem that you look at, you want to always look for the GCF first. Do we have common factors in each term that we can bring out front of a set of parentheses and put the leftover terms inside parentheses? Once you've tried to do that, then it's about how many terms are you looking at in this expression. If you have 4 terms, you should try factor by grouping. If you have 3 terms, well, we just have looked at a method for trinomials that start with x squared. But there's a different set of steps for trinomials that start with an x squared that has a coefficient that's not 1. So trinomials that start with 2x squared or 3x squared, they have their own way. So you want to be clear about the set of steps we've just learned are great for trinomials that have 3 terms, and that first term is x squared.